27. Tan squared x over secant x plus 1 over, and we're trying to make that left equal the right, 1 minus cosine x over cosine x. Okay. As you look at the start, what do you see?
The cosine system. Pythagorean identity. That's what I did for the top.
I would see Pythagorean identity here. And the advantage of Pythagorean identity is, okay, so tan squared x can go into a Pythagorean identity that involves secant. And what's my denominator have in it? Secant. And so that's the connection I see there. So according to our Pythagorean identity, tangent squared x would be what?
Secant squared x minus.
Secant squared x minus 1 if you manipulate it. Do I need to write that out more than that?
That's right, I'm okay.
Okay. So this would be the first step I would expect to see. Now, if you found a totally different way for this to happen, and the steps all follow legitly, then that's fine. Okay? I'm never going to argue that there's not a totally different way you could go. You have to show it to, it has to make sense. It has to follow. Okay. What's my next step here? There's a good way to go and a bad way to go.
I think I want the bad way.
And the annoying part is they both end up with the same result. But one of them I won't give you full credit for.
Cosines?
Not yet. Well,
Spread out the secant, like the secant squared, and the secant.
as in, so secant squared minus 1, what can it do? It can
Secant x minus 1, secant x plus 1.
it can factor, like difference of squares. Now, if you change it to cosines right there, I think you'd still end up having to factor. Now, that's an actual interesting, oh, but you'd have 1 over cosine. Yeah, no. Okay. Now, we're going to factor that numerator. That's the correct way to go. Here's what you can't do. It's not legal to say, oh, secant divided by secant is secant. Minus 1 divided by positive 1 is minus 1, so secant x minus 1. Show me the factoring step so I know you did this legit. Okay? So on top, think difference of squares. 2 parentheses. Secant squared x breaks into secant x times secant x. 1, the square root of 1 is 1, so 1 times 1. How do you multiply to get negative 1? Positive 1 minus 1. And my denominator is still secant x plus 1. With that in mind, what do you see?
The secant x plus 1.
Secant x plus 1 cancels with secant x plus 1. That's a factor. You're canceling the entire denominator with a factor in the numerator. That's legal. What remains? Secant x minus 1. Okay. This is where I pause and say, okay, I don't know what to do now. Where are we headed? We're headed to cosine world. And what do we know about secant? It's 1 over cosine, yes? So I would definitely go the direction of, okay, let's convert this secant to a cosine. So secant x is 1 over cosine x. Now, the minus 1. And this is where, I'm going to erase this, I'll be honest. If I put that minus 1 there, I'm still kind of, what am I going to do with this, right? But right now, notice I have something minus something. My answer ends up being expressed as 1 fraction. So how do I get this to be 1 fraction?
Right, 1 is cosine x over cosine x.
Yeah. What is 1 with the common denominator of cosine x? Okay. And 1 is something divided by itself. So in this case, to get the common denominator of cosine, I'm going to say cosine x divided by cosine x. Okay. I think that's a trick right there. Understanding how to do that is a key thing. I know we did at least once or in the notes. Now, what do I have happening here? Fractions being subtracted with a common denominator. So what do?
Subtract across.
Yeah, keep the denominator, subtract across. 1 minus cosine is 1 minus cosine. What just happened?
You did it.
We got there. I got extra space, but we got there, right? Now, I don't know if there's any steps you could have skipped and I would legitimately believe that you're there. It's possible, but, you know, make me believe you understand that. One of the big ones is I would say I'd like to see the factoring, because otherwise I'm going to question if you just divided illegally. Okay? Okay. There's one. What else?
30.
30?
Mm-hmm.
Okay, which way are we starting? Tangent squared minus sine squared? So tangent squared theta minus sine squared theta equaling to, where am I trying to end? Tangent squared theta times the sine squared theta. Okay.
I started by trying to put everything into sine and cosine. Oh wait, yeah, I did. Never mind.
Possibly. That's why I'm trying to process, and I haven't looked to see what I've done, but I guess what I'm doing is in my head I'm going through options, and about the only option I see right now working is putting things into sine and cosine. I don't know if you guys, I was thinking about Pythagorean identities, but tangent squared is going to give us a secant squared minus 1. The sine squared is going to give us a 1 minus cos. Like, there's just not.
No. Those are up.
It might get you there. I'm not going to say it wouldn't, but I'm not sure it's going to be any better than trying to do this. So, okay. So, sines and cosines. What do we know about tangent squared?
It's sine squared.
Okay, sine squared over cosine squared minus, I'm going to go ahead and set this up as a fraction because I have a feeling that's the direction we're going to go. Sine squared over 1.
Yes.
And here's one of my reasons. Why do I think we're going to go fraction minus fraction? Because eventually my answer does not have subtraction in it, does it?
No.
My answer is one term. It's not something minus something. So that's where I see this going. Okay?
I multiplied sine squared theta over 1 by cosine squared to get a common
Common
denominator.
denominator?
That's why I did it.
Yeah, and that's where my brain is going. It's funny, I kind of glanced in my notes just to see, okay, make sure we don't go off on some wild tangent. And I have this problem worked 3 different ways. So, but yeah, if we try and go for a common denominator is going to be cosine squared. So that means this second fraction is going to have to be multiplied by cosine squared theta over cosine squared theta. So then I'm going to have sine squared theta over cosine squared theta minus, well, what is sine squared times cosine squared? Yeah, sine squared cosine squared theta all over 1 times cosine squared is cosine squared. Nope, not at all. In other words, you're talking about what I'm getting ready to do in the next one.
Yes.
Yeah, and that's a step that you could leave out. So fraction minus fraction, they have a common denominator. So what is the point once you have a common denominator? Write your common denominator and put them together, right? So what am I doing? I'm going to say sine squared theta minus sine squared theta cosine squared theta.
This was where I didn't know what to do because I didn't know what to cancel or what not to cancel.
Okay. Now, okay, real quick. So Emma, you're saying you just skipped straight to this step and you did not write this step, correct?
Mhm.
I'm perfectly fine with that. Okay? I honestly, if I was doing it, that's what I would do. I hesitate sometimes just because who am I going to lose along the way? So, but yes, that's perfectly fine. Okay. So in terms of what to do next, well, I'm going to say there's no canceling I can do right now because there's only a cosine squared in the denominator and only one term in the numerator has a cosine squared. So I can't cancel anything.
Factor out a sine square.
Both terms on top have a sine squared. So think GCF on top. I do agree with that. So if I factor out a sine squared on top, sine squared divided by sine squared leaves me with 1 minus sine squared cosine squared divided by sine squared leaves me with cosine squared all over cosine squared. Did she just say O?
Yeah.
Okay.
It wasn't that hard.
Because now you see it?
Yeah.
And sometimes it's just that one little connecting step that, okay, what should we do next? Because we are almost there if you don't see it.
Rewrite 1 minus cosine squared theta as sine squared theta.
Yeah. If you start looking at, we need a tangent and a sine down here, a tangent squared and sine squared. Right here, this guy, 1 minus cosine squared, is a Pythagorean identity, yes? 1 minus cosine squared is going to end up equaling sine squared. So we already have sine squared theta on top, times now another sine squared theta, all divided by cosine squared theta. Do you see the pieces?
Yes.
Okay. And honestly, you could go right here what I have to the answer. I mean, you're good. I see the pieces. You see you recognize the pieces. We're there. If you wanted to make it clearer, the only other thing you could do is break this into two pieces, right? Whereas there is a sine squared theta over cosine squared theta times, what's my other piece? Sine squared theta over 1. So that's, and I'm not saying that's a required step right there. It's not. Okay, but if you're struggling to see it, that's sine squared over cosine squared. Well, sine squared over what else? Just 1. There's nothing else to break it into. And sine squared over cosine squared is tangent squared. Sine squared over 1 is sine squared. We're there. Okay.
I just want to make sure
Bless you.
I started 39 correctly. Because if I didn't, then I did all mine.
39? Okay. So, sine t over 1 minus cosine t. And then what? I can't remember anything today. Plus cosine t over sine t. And then we are trying to make it equal to times 1 plus what? Cosine t over sine t. Katie, is this the one we worked on?
Yes.
Okay, you had already started it, so I never pay attention to what the beginning was, but this is the one that I helped you in the middle on? Okay.
Yeah.
Okay. So I know where to go in the middle.
Okay.
I know where I'd start looking at the beginning, so it's just putting all the pieces together. So, okay. Where are we going to have to start? We got two fractions. They're already all in sines and cosines, so it's not like that's an option. There's no squareds, so it's not like Pythagorean identities are an option. When I go to my answer, well, yes, there is addition in it. There's one fraction in my answer. So that's a clue that we might want to go ahead and put them together. What is my common denominator?
1 minus cosine t.
Yep. And I tend to put sine t first, but sine t times 1 minus cosine t. Sine t times 1 minus cosine t. Okay. First fraction, what is it missing?
Sine t.
It's missing the sine t. So I'm going to multiply the denominator by sine t, and that means I'm multiplying the numerator by sine t. What is sine t times sine t? Sine squared t? Okay. Second fraction, what's my denominator missing? 1 minus cosine t. So that means I'm multiplying my numerator by 1 minus cosine t. Now, for this moment, I'm going to write it out as 1 plus cosine t times 1 minus cosine t. But what are you going to have to do? Or what should I maybe already have done based on the look I'm getting? Should we go ahead and multiply that?
Yeah.
Well, are you saying combine it as in?
I say go ahead and multiply first. I don't really figure it out.
Okay. And both need to happen here. Okay? I'm getting a weird look over there, so I'm not sure that. Okay. First of all, fraction plus fraction that have the same denominator, yes? So we can put it together as one fraction. Common denominator being the sine t times 1 minus cosine t. Now, numerators. Sine squared t plus, what do I need to do with this here?
Distribute.
FOIL, distribute. You need to multiply those, and maybe you already did that. Okay, so we need to multiply. So 1 times 1 is 1. Now, 1 times minus cosine t for my outsides is minus cosine t. Insides, cosine t times 1 plus cosine t. Those outsides and insides are going to cancel. And I knew to expect that because they're conjugates, right? And then lastly, cosine t times minus cosine t minus cosine squared t. Yes?
Yeah.
Okay, this looks familiar from what I did in homeroom, right, Katie?
Yes.
This is about where, okay, this is where. Okay. What do we see? We've got squared trig functions, added, subtracted, and ones. Okay. Now, the common mistake here, at least the mistake we talked about in homeroom, sine squared plus cosine squared is what you're probably looking for. But, bless you, it's an easy day in here, geez. Do we have sine squared plus cosine squared?
No.
We don't. We have a sign that doesn't match up. Not to say it's a mistake, it just doesn't match up with what we need. Think about your Pythagorean identity in a different way. And there's probably two different ways we could go with this, but what do you know if you think about your Pythagorean identity, instead of using sine squared and cosine squared, use the one and one of the others? The easier way to go for me is, what do you know about 1 minus cosine squared? That is sine squared, right? The sine squared plus cosine squared equals 1. So if you subtract over cosine squared, that's sine squared. So I would use the Pythagorean identity and say sine squared t plus sine squared t, and then still over sine t times 1 minus cosine t. I am opting not to multiply my denominator together because I know in my final answer I need a denominator of sine t. So that's one of the reasons I'm not distributing and multiplying together. Okay? Clean up your numerator. What's sine squared t plus sine squared t? 1 sine squared t plus 1 sine squared t is 2 sine squared t over still sine t times 1 minus cosine t. I promise we're getting close. I don't know if you see it personally or not, but I promise we're getting there. Jump ahead to your answer. I need the sine t on the denominator, but I need the 1 minus cosine t to be gone. On top, I need the 2, but it's not a sine squared I'm supposed to have, it's a 1 plus cosine t I'm supposed to have. Do we see it or not see it?
Break up the 2 sine squared.
Okay. In terms of,
Factor out a 2 and then break it up.
well, what we've got to think about though is, what is sine squared t? Because I still want a sine t to be on bottom, so I don't want to cancel.
It's cosine squared t minus, or 1 minus cosine squared.
Okay. It seems like we're going in a circle here, I know, but I'm not sure if there's a better way to do it without going in a circle. Which number is this?
39.
39. Oh, we could have done it the other way.
I think
Okay.
I did it the other way. That's why I'm so confused.
When did you do it the other way? Up here?
Yeah, like right there.
Okay. And that is an option. So, okay. Let me finish this one real quick. So we're not, and then we can look at the other way
This
there real
one's,
quick.
like, really confusing.
Okay. So, and this is what I'm realizing. Okay, sine squared t. Think Pythagorean identity. What is sine squared t in a Pythagorean identity? Sine squared t in a Pythagorean identity is what? Subtract over the cosine squared, so it's 1 minus cosine squared t. And then we still have over sine t times 1 minus cosine t. Oof, I gotta be able to fit one more line of work in there. We did this skill already today. What do you know about 1 minus cosine squared t? It factors. It's a difference of squares. Okay, so the 2 stays on top. 1 times 1, or 1 breaks into 1 times 1. Since that's in the front, these go in the front. Cosine squared is going to break into cosine t times cosine t. And then since it's 1 minus cosine squared, we're going to say 1 plus and 1 minus. And then it's over sine t times 1 minus cosine t. And what happens? 1 minus cosine t can cancel, yes? And you have all the pieces there. Now, and this is one of those, maybe I should have looked earlier in my notes. Emma, did you go a different way right here?
Yeah.
And what did you do?
Well, I erased it because I thought I was doing it wrong. But I had like, I just erased it because I thought I was doing it wrong.
Well, because the other option is to use this as a Pythagorean identity.
Yeah.
Okay, so sine squared, if we rearrange that Pythagorean identity, what is sine squared?
Cos squared plus
No,
1 minus.
it'd be 1
Oh,
minus
yeah.
cosine squared, right? So sine squared can become 1 minus cosine squared t, plus we have another 1 minus cosine squared t, still all over sine t times 1 minus cosine t,
Yeah,
okay? Now, if you were headed this way, this would have worked too. If someone would have said this, I would have gone this way too.
I just thought I was doing it wrong.
No.
Like, just figuring it out.
On top, collect your like terms. What cleans up on top? 1 plus 1 is 2. Minus cosine squared t minus cosine squared t is going to be,
Plus.
no.
No, minus.
Think negative 1 cosine squared t minus 1 cosine squared t.
Minus 2 cos.
Minus 2 cosine squared t
Yeah.
over still sine t times 1 minus cosine t. On top, what do you notice about those two terms in top?
Factor out of 2.
They both have a GCF of 2. So if we factor out of 2, 2 divided by 2 is 1, minus 2 cosine squared t divided by 2 is minus cosine squared t, divided by sine t times 1 minus cosine t. One more step and you're there.
Yeah, because I got to that like way before you did on the other one, and I was like, wait, like maybe I didn't show enough steps.
No,
But if I did it the other way, like,
we have one more step that you have to show to make me believe you know your steps. And that is, what do we know about 1 minus cosine squared t?
if you can.
Didn't we already do that over there?
Yeah.
It factors. So the 2 stays 2. 1 breaks into 1 times 1. Cosine squared breaks into cosine t times cosine t. Multiplying to be a minus is a plus and minus.
And then you can cancel that.
All over sine t times 1 minus cosine t.
You doing it that way just solves number 30.
Okay.
Not for me, I'm still very confused.
Okay. So I now have 2 times 1 plus cosine t over sine t.
Alright.
Now, the advantage of me working this out both ways, I mean, it took a little bit of time, but this is where I'm going to say, person A does that way, person B does this way. You're both equally correct. Okay? Is there possibly a person C option? Sure. I don't know what it is right offhand, but again, if your steps are true and make me believe, then it's good. Okay? So, yeah. And it's all in the eye of the beholder. What comes to you first? That's what it, goes down to. I'm never going to just say, oh, you went a different way there, you're wrong. I'm going to follow until you get a step wrong. Then I'm going to say, okay, now you're wrong. Okay. Okay, where am I supposed to be going next?
36. I tried it again, and I feel like I'm like almost there, but I just can't.
Almost there, but not there? Let's see, we don't need this page anymore. Okay, 36 is sine over 1 plus cosine. This seems like a very familiar problem to begin with. Plus 1 plus cosine t over sine t. Where am I going with this? Okay, very different ending though, huh? 2 cosecant t. Okay, well, I don't know where I'm going along the way, but I know where I'm going to start.
Common denominator.
Yep, we need to get to this. We're trying to go into one trig term, folks. That mess, one trig term. Common denominator. What is my common denominator?
1 plus, or sine t plus, multiplied by 1 plus.
Okay, sine t times 1 plus cosine t. I don't care which you put first. It's the two denominators meshed together. First fraction, what's missing? Okay, it has 1 plus cosine. We're missing sine, so we're going to multiply top and bottom by sine. What is sine t times sine t? Man, I do feel like I'm reliving the same problem. Okay, second denominator, what are we missing? 1 plus cosine t. But here's where it's going to change up. So what am I multiplying my numerator by? 1 plus cosine t. Now, do you want me to go ahead and multiply it out this time?
Yes.
Okay. So if we do that, you're foiling, yes. What's different about this one? I said this is where it changes up.
They don't cancel.
My middles don't cancel, do they? So you're going to have 4 terms combines to be 3. So first, 1 times 1 is 1. Outsides. 1 times cosine t is
2 or
1 cosine t. Insides, cosine t times 1 is another 1 cosine t. What's 1 cosine t plus 1 cosine t? That is 2 cosine t. And last, cosine t times cosine t, cosine squared t.
Yes.
Okay. Common denominator? Okay. I've got 2 fractions, same denominator, so I'm going to write it together as 1 fraction. Denominator is sine t times 1 plus cosine t. Maybe I'll need to multiply that eventually, but I have no reason to believe I'm going to multiply that together ever. We'll see. Okay, numerator. I put this all together. Sine squared t plus 1 plus 2 cosine t plus cosine squared t. Okay. Have it as 1 fraction. Now maybe you did that. Maybe you just wrote 1 step so far. It's possible. Now what?
I did a sine t plus a cosine t is 1.
Okay. Specifically sine squared t plus cosine squared t. Pythagorean identity here is what I would see at this point. Is that what you didn't see?
Well, it's because they're
I
all the way
changed the
much
sine
different
to
than
1 minus cosine and tried to factor a cosine.
Well, if you change sine squared t to 1 minus cosine squared t, that would work because then your 1 plus 1 would be 2 and your cosine squared t's would cancel. That would work also. You could go either way with this one. So like what I tend to see, that doesn't, is that sine squared plus cosine squared, that is a Pythagorean identity, and that is going to equal 1. So then I have 1 plus 1 plus 2 cosine t over sine t times 1 plus cosine t.
If we just go to that without showing the Pythagorean identity, without adding it as a step, if I just did it like that, that's fine.
Like what I just did?
Yeah.
Yeah. Because I didn't rearrange these?
Right.
That's fine.
Okay.
I mean, I kind of underlined mine, but if sine squared and cosine squared disappear and there becomes a 1, I'm fine with that. Okay? I personally would always do that. I just didn't when I was first teaching you because
Yeah.
you guys would have been like, whoa, what just happened? So think how much you've grown in like a week. You don't think it's crazy anymore, right? Caitlin, what I was going to say here is if you instead, and I'm not going to work this one all the way out, but if you had said sine squared, is this what you did? 1 minus cosine squared?
Yeah.
Then you still have a 1 plus 2 cosine t plus cosine squared t, right? So if you did that, well, here's the deal. 1 plus 1 is 2. Minus cosine squared t plus cosine squared t cancel. And then you have 2 plus 2 cosine t, which what am I getting ready to have on my way?
Yeah.
Okay, so legit both ways, right? Like terms, 1 plus 1 is 2. And I have 2 plus 2 cosine t over sine t times 1 plus cosine t. Okay, so just to prove to you what the step you took is good, whether I think you were just not going to this step correctly. So, okay, one last big step. What do you have to see here? There is a
2. Factor out.
A GCF of 2 is what you need to see here. If I factor out that 2, you're there. 2 divided by 2 is 1 plus 2 cosine t divided by 2. Cosine t. Divider all over sine t times 1 plus cosine t. And what happens? 1 plus cosines cancel. And I am officially at 2 over sine t. But sine t is the reciprocal function of cosecant. And so a sine in the denominator is equivalent to a cosecant on top.
Yay.
And we're there.
We did it.
Okay? I am going to want them. Okay?
Yes.
They're good stuff. Okay? You just got to keep working on seeing the steps, connections. Did we help out with some of the issues?
Yes.
Okay, good.